Hello and welcome to another session in physics. In this session we will be looking at the topic measurements of mass, weight, length and time. But before that, let us review the previous lesson. Well, as you can see from our slides, today we'll be talking about the measurements of mass, weight, length and time. And in the previous lesson we said that mass, length and time, they are all fundamental quantities, and their units respectively are kilogram for length and for mass rather, and then for length the SI unit is meter, and then for time the SI unit is second. So we can see here that measurement is an important aspect of physics. Like we emphasized earlier in our previous lesson, we said no law is established, no fact, no principle can be stated unless it can be specifically measured and quantified. And now, seeing that physics is all about measurement, every such measurement requires two things. The first is that it requires a number. That number will be used to quantify that object, a number or a quantity. And the second is that it requires, so we have first a quantity and then we have a unit. Remember in previous lesson I told you that, let's say you want to go buy rice from the neighboring shop. The rice is the name of the commodity you want to buy. That is the quantity itself, rice. And now secondly, when you get to the shop, you have to tell them, this is how much rice I want. For example, like I want 5 what? Is it 5 liters of rice? Is it 5 bowls of rice? Or is it 5 cups of rice? When you choose cup, you'll see here that cups refer to the units which will be used to buy. So, another example we have here is that of something like, let's say you're trying to measure the length of a football field. You can say 20 what? 20 meters. 20 meters is the length of a football field. Now let's look at how to measure length. There are so many instruments that we can use to measure length. The first of them is the meter rule. The meter rule is often used to measure distances that are of a few centimeters. For example, let's say the length of your desk, or the length of your textbook, length of your exercise book. These are things that have a distance of few centimeters. Dimensions of a room, the distances are not too long. But when longer distances are involved, of course, you're going to need an instrument that can go as long as possible. In that situation, we use something like a tape rule. That one you pull out and it can get very long. Now, we have units of 0.1 cm or 1 millimeter. These are the smallest graduation on a meter rule. Smallest graduation on a meter rule can either be 0.1 or 1 millimeter. Now, another instrument we can use in measuring length is the caliper. Calipers are used to measure distances on solid objects, because matter exists in 3 forms. We have solids, we have liquids, and then we have gases. So we use calipers to measure distances on objects. Why do we use calipers to measure distances on solid objects? There are some situations where an ordinary meter rule cannot be applied directly, so we have to make use of calipers. Precisely, the name is vernier caliper. So how do they operate? These vernier calipers are made up of hinged steel jaws which are closed and clamp on the desired object that is being measured, and they can enclose that object. Now the distance between the jaws, like you can see on the diagram here, we have 2 jaws here. The distance from here to here, for instance, gives us the diameter or the length of that object that is being measured, and then we can graduate the measurement on a meter rule. We also have another instrument called the micrometer screw gauge. The micrometer screw gauge even helps us to measure smaller lengths. For example, think of a wire, the diameter of a wire. A wire is so small that you cannot even begin to think of measuring a wire, the diameter or the thickness of a wire. We can also use the vernier caliper to measure a wire, but the thing is that the micrometer screw gauge gives us more accuracy. And in physics, accuracy is of essence. It gives us more accuracy because it can read to measurements of higher values such as 0.01 millimeters or 0.001 cm, it can be graduated to very small quantities. Apart from the fact that we can use it to measure the diameter of a wire, we can also use it to measure the thickness of a piece of paper. Imagine trying to measure the thickness of a piece of paper. That's not easy at all. You need something that can be graduated to a very small degree of accuracy as possible. And then we can also measure the diameter of a small ball, such as a pendulum ball, which we use in experiment. So this is the diagram of the micrometer screw gauge. Then you have things like the frame, the anvil, the spindle, the sleeve, the lock, the thimble, the ratchet knob. At your own time, you could practice drawing this and labeling it as well. Time is also a fundamental quantity. We define time as an interval between two events. In other words, the difference between the period that two events occurred. Let's say you had breakfast by 7 and then you went to school by 9. The time interval between 7 and 9, that's 2 hours. 2 hours gives us time, and that's how we measure time. Now, we have some instruments that help us to indicate what time of the day it is. Of course, we're familiar with that. Watches, we have stop clocks, we have the wall clocks in our houses. In Olympic Games, these are stopwatches that are used. They come either in digital forms or in analog forms, and they are used to give us a representation of time. And then when it comes to mass too, we have so many instruments that we can use in measuring mass. Let me take this time to define what mass is. The mass of a body simply refers to a measure of the quantity of matter that this body contains. Usually we measure mass by using an instrument called a balance. Could be a spring balance, could be a beam balance such as the one you're looking at here. We also have a chemical balance, which is also a beam balance. We have the dial spring, we have the direct reading balance. The next slide is going to show us what some of these instruments look like. This is the dial spring. It is in some shops. For instance, when you want to go buy some meat or fish, they put it here to weigh the mass or the quantity of fish you're trying to buy. And this one is called the lever balance as well. We also have the spring balance, which uses the principle of gravity to help us to measure the weight of a body. There is a big difference between mass and weight. Some people think that when you stand on a scale, you're measuring your weight. Of course, you're not measuring your weight. What you're measuring is your mass, because the SI unit of mass is kilogram, whereas the SI unit of weight is Newton. So if somebody asks you, how much do you weigh? You start telling the person 500 newtons. Not at all. You tell the person, probably, I'm weighing 50 kilograms. That is because mass is a measure of the quantity of matter, a measure of the quantity of stuff contained in you. Your intestines, your hands, your leg, your head, all these things contribute to make up the total mass of your body. On the other hand, weight is a force. Weight is a vector quantity. Mass is a scalar quantity. Weight, the gravitational force acting on a body due to the Earth's pull. That is the reason why when you throw a substance up, that substance must surely come down. That is because of the weight acting on that body. And this is the instrument we use to measure weight. Now let's look at the differences between mass and weight in a more broader sense. We say mass is the quantity of matter present in a body. On the other hand, weight occurs due to the force of gravity on an object. Mass is constant, weight varies. Mass is a scalar quantity, weight is a vector quantity. The unit of mass is kilogram, the unit of weight is Newton. Mass is measured using chemical or beam balance, weight is measured using a spring balance. The principles of moments are used to obtain mass. On the other hand, the instruments for measuring weight obeys Hooke's law of elasticity. Now, the relationship between mass and weight is gotten from W equal to mg. In other words, weight is equal to mass times acceleration due to gravity, which is measured in meter per second squared. So let's say my weight is 500 newtons. What is my mass? my mass, what will it be? Of course, we know G is given as 10 meters per second squared. So all we just have to do is from W equal to mg, we just have to make m the subject of the formula by dividing both sides by G. We divide both sides by G. M equal to weight over acceleration due to gravity. So the mass becomes weight 500 over 10 acceleration due to gravity. You discover that your mass is 50. On the other hand, to convert 50 kg to weight, all you just have to do is multiply it by 10, which is acceleration due to gravity, and you go back to 500 newtons, which is your weight. Now, when we want to measure volume, we use an instrument called a Eureka can. This Eureka can is a graduated cylinder that helps us to measure volumes of liquid, and it helps us to measure volumes of irregular shaped objects such as stone. Thank you for joining us in this lesson. To refresh your memory on what we've just discussed, please take the test that will appear on your screen.